In this video, we're going to measure the current of an electrical circuit. I'm going to use this Microtrainer, a board I created for electrical training, and this Fluke 15B multimeter. Most multimeters have the ability to measure current. So we're going to be dealing with this side of the multimeter. So I'm going to rotate my rotary switch over. I'm going to put it here in the middle. So this is the milliamps. We measure current in amperage. I have three options here: amps, milliamps, and microamps. And then above each of these, I have either direct current or alternating current. Depending on your multimeter, it will default to one, and then you have to switch it to go to the other. So this multimeter, if I press the yellow button, that switches to the alternating current. So if I look up here, this says alternating current, and I press it again, and now I'm reading direct current. So I want to make sure that I'm in the correct settings. So that's the first thing that I need to do. The next thing that I need to do is down here at the bottom, I need to change the position of my red meter lead. I have two options here. I have the milliamp option, so here's milliamp and microamp, and then I have amp. You need to know before you measure approximately how much current is flowing through the circuit. When we measure current with the multimeter, the current flows through the multimeter, and so I have a fuse to protect that. The milliamp and microamp fuse in this multimeter is 400 milliamps, and the amp fuse is 10 amps. And so I want to have a good idea of what the current is before I make my measurement in order to protect the multimeter and not destroy the fuse. So we're going to measure in milliamps. So I'm going to take my red probe and I'm going to move it over to the milliamp probe. The dial, the rotary position, will determine which one of these, if it's milliamp or microamp. Okay, so let's make our measurement. So I'm going to turn the master switch on this Microtrainer, and then I just want to test to make sure the light turns on. So when I slide that switch to the on position, that light does illuminate, so it looks like everything's working correctly. I'm then going to take my multimeter leads and I'm going to place my red one right here. And then before I do it, let's talk about what we're doing. I'm going to put my black lead after the switch. This is going to allow me to bypass the switch. So what's happening is that the current is going through the red meter lead and coming back through the black meter lead in order to illuminate the LED. We haven't talked about this yet in this series, but there's two conventions for discussing the movement of current through an electrical circuit. We have conventional that states essentially the current goes from battery positive to battery negative, and we have the electron theory that essentially says that it goes in the opposite direction from negative to positive. Nearly every schematic that we will utilize for diagnosing, especially in vehicles and a lot of other electrical wiring diagrams, are built around the concept that the current flows from battery positive to battery negative, when in fact it actually goes in the other direction. For the purposes of moving forward, we're always going to be using the conventional theory from positive going to negative. It really isn't super critical that you understand the distinction between those two for the types of diagnostics that we will be performing. So I'm going to have my multimeter, I'm going to have the current is going to go up through my red lead. It'll then travel through the multimeter. It's going to go through that fuse that we discussed, this 400 milliamp fuse, then go out the black lead as soon as I have a complete path for the current to flow. So I'm bypassing this switch, which is in the off position. If everything is working, I should see that light now illuminate. So the current is bypassing the switch, and it's like I've just turned the switch on. So now I'm measuring 3.18 milliamps of current. So 3.18 milliamps to turn on that LED. While we're here, let's measure these other circuits and see that there's a little bit difference in the amount of current that flows through. I'm going to keep my master switch in the on position, and then I'm going to go to the B positive of this series circuit, and then go on the opposite side. This switch is in the off position, and I should see those two lights illuminate. So we can see that we're 1.41 milliamps of current in this one. And then the last one is this B positive of the parallel circuit. Now, it doesn't actually matter which one of these that I touch because the current is going to go in either direction and they should illuminate both these LEDs. So if I touch that one, 6.38, and I touch that one, 6.39. So just a slight variation based on the precision of the multimeter. But we'll go and discuss the differences of current flowing through a series circuit and a parallel circuit in a future video. We just want to use this opportunity to practice measuring the current in a circuit. So the steps are that I need to measure the current in series. And so I have that here on the back of the card. So if we look right here, this is a reminder when I'm measuring current, the meter is in series with the load. And the way that you want to think about that is you want to think about the current is going through the multimeter, the lead, up through the fuse of the multimeter, and then back out, and that is allowing us to complete the path of electricity to the negative terminal of the battery. I could actually measure this in reverse. This will give me a negative number. It should be pretty much the same number, but it's a good idea to maintain the correct polarity when we're making these types of measurements. So I want to make sure that I put my red meter lead here and my black meter lead here. The thing that you want to be careful of is, remember, if you don't know what the current is beforehand, making that measurement, you could cause a problem with blowing the fuse in your multimeter. So we got to have a rough idea of what current should flow, and we'll have a future lesson on ways to be able to figure that out.